Okay, in this video, we're going to show you the basics of how to calculate line integrals for work done along contours. So we are going to find the work done in moving an object along the given path under the influence of a vector field. There are two vector fields given here, F and G. In part one, we are going to find the work done in moving an object from -211 to -25, then to 15 along a polygonal line. So from this point to this point, straight line, this point to that point, straight line, and then under the force F. Then something similar in part two, given different polygonal line, this time under the influence of the vector G. So let's start with the first one. So first thing to do is to make a sketch of this polygonal path. So from -2, -1 to -2, 5. So -2, -1 is going to be somewhere there. -2, -1 in the third quadrant, straight up to -2, 5. So -2, 5 there. Then horizontally to 1, 5. So gonna be 1, 5 there in the first quadrant. So this is our contour, which we call C. Now, since it's got two segments, we are going to call the first one. So let's call this one C1, and the other one we're going to call C2. So, and then this one C2. So we need an equation for C1. So the equation for C1 is going to be x equals to -2. Now, if x is equals to -2, if we differentiate on both sides here, then dx is going to be equal to 0. Then the other thing are the limits of y. So along C1, y varies from -1 to 5. So from -1 to 5. So if you like, -1 to 5, those are going to be the limits of y. Then the work done is going to be the integral of f dot dr. We already explained in an earlier video. So this is going to be f is 6x squared minus 2y, that's the x component, and then 3x plus y. So 6x squared minus 2y, I, and then the second component is 3x plus y, j. So this is a two-dimensional force field, and then we're going to take the dot product of this with the differential of r. So dr is going to be dxi plus dyj. We don't need the k component because this one is the force is just two-dimensional. Then if we take the dot product there, so we're going to have 6x squared minus 2xy dx, and then there's going to be 3x plus y dy. Okay, so that's what the work or the integral becomes. Now, from the contour, so along C1, x is 2, and so dx is 0. What this means is that along C1, this term is going to vanish. And so our integral is simply going to be the integral of 3x plus y dy. So that's the first thing. The second thing, x is -2. So whenever we see x, we can plug in -2. So this is C1 here. So we're going to have 3 times -2 plus y. Now, since this now is just an integral of y, that means the limits here that we need are the limits with respect to y, which is we obtained there. Y goes from -1 to 5. And then this is now just your ordinary scalar integral. So that's going to be y squared over 2 minus 6y from -1 to 5. I'm going to skip the steps here. If you do the calculations, this is going to give us 24. So this is saying moving the object from this point to that point, the work done is -24. Then now we need to work out this segment from -2,5 to 1,5, which we've called C2. So along that one, y is equal to 5. If y is equal to 5, then dy is 0 if we differentiate on both sides. The limits of x this time, so along C2, x goes from -2 to 1. So there's C2, x goes from -2 to 1. So that means the integration limits in terms of x will be from -2 to 1. Then we go back to this same integral here, but now we are doing C2. So the work done along C2, so again 6x squared minus 2y dx plus 3x plus y dy. However, this time dy is 0, so this term is going to vanish. And then along C2, y is 5, so we're going to plug in 5 here. So we're going to have 6x squared minus 2 times 5 dx. This integral depends on x only now, so that means for the limits, we just need the limits of x, which is -2 to 1. So I'm going to plug in -2 to 1 here, and then integrate. Integral of 6x squared is going to be 2x cubed. Integral of 10 is going to be -10x. So this thing from -2 to 1, if you plug in 1, it's going to be 2 minus 10. And then take away, if you plug in 2, it's going to be 2 times -8. And then take away 10 times -2. This is going to be -8 minus -16. -16 plus 20. So this is going to be -8 minus 4, I think. So this is going to be -12. So that is the work done along C2. So that's from -2,5 to 1,5. So that means the work done along the whole contour is going to be the work done along C1, plus the work done along C2. So finally, so work done is going to be F dot dr along C1 plus integral of F dot dr along C2. Work done along C1 we found to be minus 24. Work done along C2 is minus 12. So the work done along the whole route is going to be minus 36. All right. So at this point, we're going to give you an opportunity to have a go at part 2. So in part 2, you are wanting to find the work done along the polygonal line from minus 24 to 14. Then from 14 to 1 negative 6 under the influence of the force field G. There is G there. So if you want to pause the video and then have a go at this, and then of course when you proceed with the video, then you can compare with our solution. All right, we're now going to scroll down to our solution for part 2. So the first thing we do, like we did in part 1, is a sketch of the contour. So from minus 24 to 14 is a horizontal line. Then from 14 to 1 minus 6 is a vertical line. So if we call this one C1, then the equation for C1 is y equals to 4. Differentiating on both sides here gives dy equals to 0. X varies from minus 2 to 1. So that's going to be our x limits. So our work integral is going to look like this in general. Along C1, dy is 0. So this is going to disappear, that term, and y is equal to 4. So if we plug in 4 here, then we end up with this integral here with the x limits as already discussed. Integrating this and evaluating gives us 33. Along the second segment of this line, this x is 1 here, y goes from 4 to negative 6. So we're going to have x is 1, which means dx is 0, y goes from 4 to negative 6. So if we so this integral is going to disappear. Then we're going to plug in y equals to, x equals to 1 here. So that is going to be 5 minus 2y. These are the y limits. Integrate and evaluate, that's what we find. And then combining the total work done is the work done along the two of them. So this is going to be minus 37. Okay, thank you.